Today we're talking about graphing exponential functions. Remember the format of an exponential equation. Y equals our starting value times what happens each time period. So we could be doubling, we could be cutting our population in half, right? Increasing our population by 2%. All kinds of things could be happening in our exponential function. And then to the x power, which is our time period, or more specifically, how many time periods have passed. So first, let's look at the equation that relates to starting with $3 and doubling our money each day. Again, we have y as our ending value, or our total, equals 3, which is our beginning value. 2 is what's happening each time we're doubling our money. And again, x is how many time periods have passed. So on day 0, which would be our starting day, we would have our equation y equals 3 times 2 to the 0 power. $3 is what we start with, we're doubling our money, and 0 time periods have passed. Anything to the 0 power simply goes to 1. So really this is 3 times 1, which is going to just equal 3. What happens when we substitute 1 in for x? How much money will we have the next day, which is day 1, or after 1 time period has passed? Well, in this case, 2 to the first power, which is the part I need to do first, is just 2. Anything to the first power is just itself. So 3 times 2 gives me 6. I would have $6 one day after my experiment has started. I can continue that pattern by simply filling out my table. I can have y equals 3 times 2 to the second power. 2 to the second power is 4. Multiply that by 3. After 2 days have passed, I would have $12. I can continue the next day. Oops, I accidentally put a 3 right there. I would take 2 to the third power because 3 days have passed. 2 to the third power, which is 2 times 2 times 2, would give me 8. 8 times 3 gives me 24. I'm going to continue that pattern on and on and on. You can kind of see what's happening in my total column though, right? 3, 6, 12, 24, 48. I'm literally doubling my money every day that passes. When I put those numbers on a graph, it's going to look something like this. Our x-axis is going to be the number of days. I'm actually going to put number of days instead of just days. And the y-axis is going to be the amount of money that I have on that day. So at day 0, that's when my experiment starts, or my investment starts. We started with $3. So I put the 0.03. After 1 day has passed, we found that we had $6. After 2 days have passed, we had $12, which would already be up here. And after 3 days, I'd have 24, then 48, and so on. This ends up, instead of being a linear function, starts to give me a curve. What happens when I extend my graph? First of all, let's put the numbers on that we knew. We started with 3, then 6, then 12. How much money would I have had the day before? Well, if I'm doubling my money every day and I had 3 on day 0, if I had started my investment earlier, I would have only had $1.50. And the day before that, I would have only had 75 cents, and so on, and so on, and so on. what ends up happening is I get this nice exponential curve. This is going to keep getting closer and closer and closer to the x-axis, so close that you can't even tell the difference between my line and the x-axis, but it will never physically touch the x-axis. If you keep taking half of something, right, if I'm doubling going to the right, that means going to the left, I'm dividing by 2. If I keep dividing by 2 going left, I'm never actually going to hit 0. Let's try one more. Let's try y equals 2 times 3 to the x power. Again, I'm going to start with my beginning point where x is 0. 3 to the 0 power is 1, and 1 times 2 means that I'm starting with 2. The next day, or after 1 day has passed, 3 to the first power will give me 3, and 3 times 2 will give me 6. The next day, when I have to the third power, 3 to the third power, or 3 times 3 times 3, gives me 27. And 27 times 2 is going to be way off my graph. So that's not going to be really a big help to me. I need a bigger graph. I'm going to... Oh, sorry, that's not very straight. But we will get kind of a picture here. Oops, I went down below the x-axis and I shouldn't have done that. Remember, we get really, really close to the x-axis, so close that you can't really even tell the difference between my line and the x-axis, but it never actually touches. How about 6 times 1/2 to the x? This time, on day 0, or my starting point, 1/2 to the 0 power is 1, and 1 times 6 is 6. I started at 6, which is really obvious from this part of our equation. What's happening to my numbers this time? We're not doubling or tripling. What's going on here? Right, we are losing half of our value every day. So if on day 0 I have 6, after 1 day's passed, I would only have 3. The next day I would only have 1.5. The day before that, or the day after that, 0.75, and on and on and on. If I keep taking half of something every day, my curve is going to go to the right. If I have $6 this day, the day before I would have had $12, right? If I'm timesing by 1/2 going to the right, which is the same as dividing by 2, then going to the left I would be timesing by 2. Or I could say dividing by 1/2. That would be the same thing. And this is approximately what my exponential curve would look like. And finally, what's our starting value in this equation? Where are we going to start when x is 0? At -2. This tells me that my value is doubling each day, or year or month, or whatever time frame we're talking about. So if I start at -2, the next day I would have -4. The day after I would have -8. The day after I would have -16, and so on. So this time, my exponential curve is going to face downwards. Remember that if I'm multiplying by 2 going to the right, I'm going to do the opposite going to the left and divide by 2. That's where I got the -1 and the -1/2, and the -1/4, and the -1/8, and so on, going off to the left. As long as you have an idea of what an exponential curve looks like and how to find a few points on it, it's all good for now. Make sure to write down any questions that you have and bring them to class so that you can ask them there. Have a good night and good luck.